Hi Year 12s. Today, we will look at measures of spread for continuous random variables. Like the discrete random variables, the measures of spread that we will use are the variance and the standard deviation. The extra measure that we will use for continuous random variables is the interquartile range. First, we will look at the variance. The formula for the variance is the expected value of the variance of the random variable minus the mean squared. For the probability function, this is equal to the integral of x minus mu squared times probability density function from negative infinity to infinity. The variance gives us the long average range of values that we can expect to get around the mean. There is also another formula for calculating the variance, which is a little more computational. The variance equals the expected value of x squared minus the squared mean. Next, we will look at the standard deviation. The standard deviation is also a measure of spread around the mean. The formula is the same as the one for the discrete random variable. The standard deviation of x, called sigma, is the square root of the variance of x. Now, we will look at the interquartile range, which measures the spread of the distribution by finding the lower and upper bounds of the middle 50%. The closer the bounds are together, the denser the function will be. The range is calculated through the same formula as we used for the median. We just need to solve the equation of the integral of the function f of x over the range of negative infinity to the variable p for a given percentage q. However, instead of setting q to 0.5 like we did for the median, we set it to 0.25 for the lower bound and 0.75 for the upper bound. Let's practice finding the variance using the function f of x equals 0.5x from 0 to 2. To find the variance, we will use the equation variance equals the expected value of x squared minus the mean squared. First, we find the mean through integrating x times f of x over the range 0 to 2, like we learnt in the video on continuous variables measures of centre. Then, sub in f of x, and then take the 0.5 out the front and integrate to get x cubed over 3 between 0 and 2. Once we sub in 2, we get 0.5 times 8 on 3, which is 4 over 3, which is our average. Now, we need to work out the expected value of x squared, which follows the same process, except this time we add an x squared instead of just x. So we get the integral of 0.5x cubed over the range of 2 to 0, which goes to 0.5 times x to the 4 on 4. Understand the difference between small and large variances. Good luck with your studying!